Good evening, everyone. I am Rajkumar Bagel, Application Engineer in Hioki India Private Limited. Today, I will present the Hioki solution for external and internal parameter measurement of lithium-ion battery for electric vehicles. So these are the content. First, we cover the overview of Hioki. After that, the lithium-ion battery production process, then external parameter of a battery, Hioki solution for external parameter, then internal parameter of a battery. After that, DCIR, ACIR, then measurement solution for internal parameter of battery. And after that, I just tell about the function and the features of a battery tester BT4560. And after that, key features, impedance characteristic evaluations. So now, first of all, let me brief about Hioki. Hioki started in year 1935 in Japan. Hioki provide electrical measuring instrument all over the world. So many subsidiary available in different countries like India, Singapore, just like India, Singapore, Korea, China, Taiwan, USA. So Hioki is a manufacturer of electrical measuring instrument just like ATE automatic testing equipment, data recording equipment, electronic measuring instrument, and the FMI field measuring instrument, which are used in the field like electronics components, automotive sector, infrastructure, environment, and alternative energies. Now, recently Hioki launched one new tester, BT6075 and BT6065, which is used for the measurement of IR and the voltage of a battery, and it is belongs to a battery family of Hioki. Hioki is the company which provide the first AC million high tester in 1986, and after that consistently it provide a battery testing tools. So it battery tester which is provided by a Hioki is used in all over the world in R&D as well as in production lines. So these are the Hioki starting in 1986. This is the first one, 32225, and now this is a recent one, BT6075 and BT6065. Now let me brief about lithium ion battery production process first, and after that we move towards the external parameter. So basically, in the process of lithium ion battery production, first step is to mixing. So in mixing, we mix active material, conductive agent, polymers, and organic solvent are mixed together to form electric slurry. And this slurry is again after that coated on copper and aluminum foil, and after that we can dry it and then calendering. So according to your battery requirement, you just filtering the electrode sheet as the battery side required, and after that you just stacking the filtering sheet to form a layer, and after that we can just press the end of the layer to form tab, and this tab we just belt to form only two electrodes just like anode and cathode points. So these tabs are after that belt with a cover from at which place we can connect the load, and after that we just put this in the case, and after that put in the case we can belt together case and cover, and there is a one hole is available for filling electrolyte, and after filling the electrolyte by electrolyte port we can close this port, and after that we just first charge the cell for the first time, and after that these cells are repeatedly charged and discharged during uses. And we can also put these cells for some time at one place, and after that just check the voltage so that we can check the aging effect. So and after that finally we just inspect the quality of the battery, and then after that we shipped the battery. Now, the as we told external parameter, in point one you can see tab belt resistance between collector and output terminal. We need to test the collector and output terminal belt. It must be proper, otherwise losses occur, and after some time there is a chance of a fire hazard. So this is the first parameter we need to check your tab is properly belt or not. After that, second is the insulation resistance. We need to check the insulation resistance between anode and cathode, and between electrode and the enclosure of a battery. It must be as high as possible, because if it is less, then there is a chance of a short circuit, due to which there is a chance of fire hazard. And we also need to monitor the voltage and temperature during charging and discharging here, so that when after recording the data we can analyze and we are able to rank the battery. And next parameter fourth is internal resistance of a cell or a test tube. We need to check the internal resistance after filling electrolyte, during charging and discharging process, after aging. So these are four parameter. And fifth one is open circuit voltage. In this graph you can see that if you put a battery for a some time, just like 100 hours to 400 hours, and then after that you just check the voltage by using a Hioki DC precise voltmeter, and you check that the voltage is how much voltage is dip. If it is reduced below a particular limit, then we reject the cell or battery. So by using voltmeter you can also check this quality, open circuit voltage. So basically these are the five parameters we can categorize in external parameter of a battery, because after manufacturing we can also test, and during manufacturing we can also test it. Just like a belt quality test, insulation, temperature, these all are I just explained in previous two slides. So Hioki provides a solution for the measurement of these parameters of a battery. Just like first one, resistance meter for a belt quality test, battery insulation tester for insulation test between electrode and case, data logger for recording of voltage and temperature, and after that battery tester for checking in IR of a battery, and a DC voltmeter for open circuit voltage testing. So I just explain one by one all these. First is lithium ion battery is weld quality test. If weld is not proper between the uh, flex PCB or between the cells, then there is a chance of energy loss due to this. And due to energy loss, battery may be start overheating after some time. So to check the quality of a belt, we need some instrument. So Hioki provide a resistance meter RM3545A, and the range of this resistance meter is 1000 micro ohm to 1000 mega ohm with a 1 nano ohm resolution. Similarly, before that, Hioki provide this, and the range of this is 10 milli ohm to 1000 mega ohm with a resolution of 0.1 micro ohm. And you can also provide a multiplexer card. If you need to test multiple cell or battery, then there is a multiplexer card is also available, just like here. These two multiplexer card is available in this. Second is the insulation test. It is required to test the insulation between electrode and the cathode. If the resistance between these is less, then there is a chance of fire accident. So you can provide for these two insulation tester BT5525 and ST5520 with a different voltage and the resistance. Just like BT5525 is available 25 volt to 500 volt, and the resistance ranges 0.5 mega ohm to 20 mega ohm. And for ST5520 we can measure 25 volt to so up to 100 volt you can apply and just check the insulation resistance, how much it is of a battery. Now, next one is the voltage and temperature recording instrument, that is LR8101 and LR8102. These are also a recent one which is launched by Hioki. And before that, there is one model is going on LR8423. So these are the recent one, and before that, it is this. In this, with this, you can connect 10 module with this data logger, and you can connect 10 data logger at a time. So by this combination, you can tap voltage and temperature of up to 3000 channel at a time, because in each module you can measure 30 temperature. So 10 module you can connect this, so 300 voltage, and 10 data logger you can connect by using optical. So 3000 channel you can tap at a one time. So these are the specifications of these data logger. The basic difference between these two, in this there are two LAN port and there is a optical connection is also available for synchronizing. Next one is your open circuit voltage tester. This is a DC precise voltmeter DM7275 and DM7276. The range of this is 100 millivolt to 1000 volt DC. And the best thing is it is in available in 7.5 digit resolution. So you can also test temperature by using this. And this is the second one, which is 76 model. And after that, lithium ion battery internals means IR tester. You can provide a number of tester, just like first one is BT3561, after that BT3562, after that 3563, and now recently 6065 and 6075. The range of this is 3 milliohm to 30 milliohm. This is designed for a battery test, so you can get more stable and accurate result. So the range of this BT battery tester is 10 volt to 100 volt. So up to 100 volt, you can test directly resistance of the battery. Now we move towards the internal parameter. So for internal parameter of a battery, I just find out these three parameters are important for the battery internal characteristic to know, just like electrolyte resistance, charge transfer resistance, and the diffusion resistance. So Hioki provide for these measurement for these three resistance battery impedance meter BT4560. So first we insert the battery inside, and after that we move towards in these three resistance and the BT4560. So this is a internal diagram or circuit of a battery. In this we can show the electrolyte and two electrodes, and this so the chemical phenomena occurs. And here this is the equivalent circuit of a battery. In this we just represent reaction resistance by Rs. This resistance basically represent the chemical reaction which occur at the electrode, and and sorry and Rp represent the chemical reaction electrode resistance, and Rs is the liquid resistance, which is basically a resistance of a electrolyte. Sorry, I just missed things. And now, as you know, if you want to measure the impedance, then the formula of a impedance is voltage divided by a current. So we can measure the voltage of a battery and current. So this is the equivalent circuit, and I just draw the vector diagram of this a battery, just like a resistance and reactance, and this is the impedance of a battery, and we just take at an angle theta. So basically, as we know, impedance is basically a combination of a resistance and a reactance, and we know reactance is depend on the frequency. So if frequency change, then reactance is change, and corresponding impedance is also change. So we can measure resistance and reactance at various frequency and draw one graph that is called as Cole graph, which I will explain in later slides. Now this is the equivalent circuit of a battery as I explained earlier. R1 is basically a resistance and R2 is a chemical resistance. So if R1, which is an electrolyte resistance, so if R1 is changes, so we can say that the electrolyte composition is changes. And in this case, you see that R1 is constant, but R2 is changes. So it will represent the charge transfer resistance is changes. Means there is some deposition occur on the electrode. So due to this semicircle is increases. So by checking this, we can say that okay, there is a defect occur at the electrode or in the electrolyte. Now first we little bit explain upon DCIR and after that we move towards the ACIR. In DCIR, I just connect a DC load to the battery and calculate resistance from the voltage change at that time. Means we just applied a voltage and then connect a load. When we connect a load at that time, we change monitor how much voltage is changed. By using this voltage, we can find out the resistance. So basically, in DC, this the resistance we can measure is basically a electrolyte resistance and the charge transfer resistance. So this is helpful in the production of a output characteristic. Now I just move towards the ACIR. In ACIR, I just swap the frequency from 0.1 hertz to 1 kilohertz and just find the graph of a curve, how it is changes. So here, this is RS, which is basically electrolyte resistance, and this is the RP, which is a charge transfer resistance. So battery BT4560 is an instrument we can use for find out this type of graph. So as we know, in this is a equivalent circuit of a battery. At higher frequency, the current pass through a capacitance because it offer a lower resistance as compared to charge transfer. So most of the current flow through this path, and we can easily find out the RS electrolyte resistance. And once we move towards the lower frequency from higher frequency, so at lower frequency capacitor offer maximum resistance, so most of the current follow this path, and the resistance measured by a instrument is RS plus RP. Basically it is a combination of electrolyte resistance and the charge transfer resistance. So this is basically a Cole plot, or we can say that Nyquist plot. So it is helpful for finding these resistance. Now if we conclude what is the difference between ACIR and DCIR. In DCIR, measurement under condition to the actual use. But there is a disadvantage. We need a large equipment, and in this there is a less chance of reproducibility because of charging and discharging of a battery. But in ACIR, there is small heat generating because we just inject a small current, so there is a high chance and highly reproducibility in this occur. But in this we are not test under actual use because we inject a small current and measure. So we need to just find out some relation between AC and IR and DCIR. So here there is a correlation between DCIR measurement and low frequency ACIR. So we just take two sample, battery A and battery B. For this, I just perform resistance measurement by DCIR and by ACIR, and we just plot the graph here. Just like DCIR value, we are plotted on the horizontal axis, and ACIR value we are plotted on the vertical axis. So we can see there is some relations occur. For find out the relation, we just take 24 batteries in which of 6 type, and we take 4 each. From 6 type we take 4 cells or 4 batteries, and we can just draw a graph and we can see that there is a relations occur between this. So by seeing these two graphs, we can say that strong correlation found between a measured value of DCIR and low frequency ACIR. Or we can say that low frequency ARIR is effective as an alternative of DCIR because it takes less time and there is no heavy or large machine required for charging and discharging. So Hioki provide a battery impedance meter BT4560 which is available in 5 volt, and the range of this is available in 3 milliohm, 10 milliohm and 100 milliohm. By using this instrument we are able to plot the Cole graph, and we can find out the electrolyte resistance and the charge transfer resistance, so which is helpful to know the characteristic or grading of a battery. So this is a Cole plot which I captured by using a PC app, and this is a screen where we can show resistance, reactance, voltage and temperature. And we can also integrate this instrument with LabVIEW. So by using LabVIEW you can find out the equivalent circuit of the battery. So here you can see that at this point, this red line cut, this is a zero, means where reactance is zero. So this is a electrolyte resistance, is it is approximately less than 0.042. So it is here 0.041, and we can also measure this charge transfer resistance which is here. So I just show you. I just show you one video how this BT tester will work. In this video, we are using PC app for the drawing the Cole plot. So I think there is a little bit blur image, but I just explain you. First, we just set the communication setting of a battery with a PC, just like RS232 or USB. After that, we select the analyzing mode. In this, we select Cole plot, and we just select voltage and frequency and different functions available in just I just select RXBT, means resistance, reactance, voltage and temperature. And here just select the frequency and the data points. So these is settings. We just perform settings. Now these are the create according to the number of sample points. So first we just provide the starting frequency 10 hertz and sorry start frequency 1 kilohertz and stop is 10 hertz, and we take 100 points. So now after triggering the Cole plot is start drawing. So now you see that this is a charge transfer resistance it is showing. Now this video is showing the display of the BT4560. So you see here the frequency is just decrease from start decreasing. When it's reached near to zero point 0.1 hertz, it will start taking times because chemical reaction is slower at that frequency. Now this is a one more video for drawing a Cole plot or a Nyquist plot. So in this, the point at this line is cut, means at that point reactance is zero. The value of that point of resistance is electrolyte resistance. And this point between this and this is a charge transfer resistance. So this graph showing the now I just showing the features of BT4560, just like when we use in R&D and quality insurance. So by drawing the Cole plot, you can check the equivalent circuit analysis. Just like in this figure, we can check the effect of SOC and temperature variation on impedance characteristic, or we can say that on Cole plot. So here you can see that at different SOS, just like 0%, 25, 70, 50, 75, and hundreds, the graph is changed. In above diagram, in this diagram, you can see that the data shown no much significant difference in the shape when this is the SOC is more than 50%. So by using battery BT4560, you can plot this graph. So it is helpful for knowing the SOS conditions, how change the Cole plot. And if we change the temperature, then Cole graph is also changed. So here you just see that when temperature reduced, then the charge transfer resistance is increases. Just like at 30 degrees Celsius, the semicircle is small. At 25, it is more. When reduced temperature to 20 degrees Celsius, it increase. And when we reach to 15 degrees Celsius, it is again increasing. So basically at lower temperature, it is harder to chemical reaction to occur in this the electrolyte and the electrode. So that's why the resistance is increases at the surface of electrode, and this represent that one. Now when you are using in production line, it provide a highly stable result as compared to BT 35616263A series, and also improve the voltage accuracy. Just like I'm just showing here, you just see that in this initially there is lots of fluctuation is available, but BT4560 just send 1.5 ampere current and get more stable results here. You can see here more stable results. And also we just test the variation of R at different frequency, sorry, at different speeds. So you in BT4560, there are three modes available: fast, medium, and slow response speed. So we can see that the result is approximate or mostly stable, not much more fluctuating at 0 point hertz. But same data we can also observe at 1 kilohertz approximate. So in this also our result is stable. Similarly, we check the variation of X with respect to speed. So in this same occurs, also the results are stable. Now for by using BT 4560 there is no need of charge or discharge machine, because charge and discharge machine takes much more time, but BT4560 takes very small time, like a few second or millisecond is sufficient for testing. You can also grading the cell or cell sorting by using the Cole plot. And in the field of maintenance or recycle, you can also use BT4560. So this is just summarized from at 0% to 100% SOH, discharge capacity drops significantly and impedance change is also noticeable. But when the SOH is near to 50%, the change is little change. So we get the same graph at that frequency. So we can say that impedance measurement at low frequency is useful for diagnosis in maintenance or recycling. And Hioki provider in one of the instrument, battery cell voltage generation. This is used basically used for BMS tester. So this is an instrument picture and this is the features VMS evaluation. This instrument work as a source as well as load, and also there is a one function to measure the voltage. So I just show you one video for this. This is basically a cell simulator generator. First, it is showing the preparation list, just like this is a cell generator, PC, power supply, and a BMS. For which we need to test. So this is the settings, how to change the voltage and AH of a battery. You need to create this. After creating this, you just upload in this day. Just select simulation. When the load current, you can select here negative or positive. These are the three. You just select the file which you created, and according to this voltage profile is created during discharge, and here is charge. You can also set SOH and ampere hour capacity. After this, you just simulate just like load current negative and load current positive, different charge in the discharge. When you start outputting this, means instrument work as a source. Now first you can see here BMS inrush current. So it is showing BMS consume current is about 0.2 amps here. And this is representing the balancing current of a BMS. So by changing this load current, you just check and test your BMS. Here is showing voltage charges. So thank you. This is from my side.